Hello and welcome to what is the final lecture in this series on foundations of environmental systems and society. We're going to look in more detail at humans and pollution, which is topic 5. So the main ideas that we have here. Pollution is very, very diverse. Yeah, it's a disturbance of ecosystems caused by humans. And we can apply pollution management strategies at varying levels. But first of all, we need to define what pollution is. So within the Environmental Systems and Societies course, pollution is a very definite thing. It's adding a substance or an agent to an environment through our activity, through activities of humans, at a rate that is larger than it can be made harmless by that environment. So a lot of things could actually be thought of as pollutants that we might sometimes think of in other ways, but it's to do with intensity and rate in reality. And of course we have various forms of pollution. In its broader sense, we can either define it as organic substances or inorganic substances. Yeah, organic substances are those that tend to be naturally occurring in the environment anyway, and obviously inorganic substances, we tend to think of those as chemicals, but there may be other things that we can think of as inorganic substances. But that really simplifies the ideas right down. So there are many, many other sorts of pollutant potentials that we could look at. Light pollution becoming a major problem, species that are invasive, fossil fuel combustions, biological agents, even thermal pollution. So we have various forms of pollution that actually we could consider as in much more discrete ways than just very, very broad brushstrokes. Light pollution, for instance. Light pollution is becoming a major, major problem in many cities. That's a picture of Seoul in Korea at about 9 o'clock at night. And as you can see, it's almost daylight quality light. That disrupts people's sleep. It also disrupts the ecosystem. Birds don't nest very easily in that. They're disrupted. Animals' diurnal rhythms are knocked all over the place. So we have these various forms of pollution that we should really be considering at a much more macro level. Sources of pollution as well. We can broadly define sources of pollution in the same sort of ways we could define types of pollution. We can talk about point sources. Point sources are those that are released and have an effect in the immediate environment. So here we have drilling for oil in the Caspian Sea in Azerbaijan, and oil spills from the oil drilling rigs that are actually quite old drilling rigs now wash up quite commonly on the beaches and get coated with pebbles, organisms. All the problems that are related with large oil spills actually happen on a local scale here. And then we have this idea of non-point. Yeah, again, this is an image from Azerbaijan, but there is a lot of pollution that's put into the atmosphere by factories, which create this smog across the whole of Baku, the capital city. And as you can see, you can actually almost see the particle matter in the air there. That's coming from various sources, and it could be affecting anywhere in the city. If we took that down and expanded it out to a real example, and later we'll look at the example of pollution in the Red River in Vietnam, well, we've got many, many non-points coming together to make up pollution in there. We have pollution from the domestic water system, we have pollution from the industrial water system, and we have pollution from surface runoffs. But there's various things that contribute to those that end up in the overall pollution load directly in the Red River. We can also classify pollutants in different ways. We have persistent pollutants. Pollutants like plastics that take a long time to break down. Here we have some plastic bottles in the sand on a beach. Many, many beaches around the world, almost all beaches now have plastic pollution of some sort. And even if they break down mechanically into smaller pieces, what we end up with is smaller and smaller pieces of plastic, microbeads of plastic that stay in the environment for a very, very long time. And we also have biodegradable pollutants. Some pollutants are actually things that will break down. So cardboard packaging and the tape on these packaging boxes is cellulose based. It's designed to break down, but it may actually take quite a long time to break down, and while it's breaking down in itself can create a pollutant problem. One of the problems with some of the cardboard packaging is that it actually can lead to eutrophication. It can actually add to the nutrient load in places because it's an organic product. So we have some of these problems. And some biodegradable pollutants are not things you think of automatically as being biodegradable. Engine oil is biodegradable. It will break down over time, but it takes a long, long time and very, very specialized organisms. So while it's breaking down, these reclariant biodegradables, things that hang around for a long time, are still causing high levels of pollution. Yeah? And we can classify the effects of the pollutants. We can have acute effects, yeah, and we can have chronic effects. Again, traffic congestion, pollutants being put up by engines throughout the world, especially in the rapidly growing and developing economies in Southeast Asia, are creating major, major air pollution incidents. But those air pollution incidents are creating really, really bad chronic problems of health, including asthma, respiratory failure, etc., etc. So yeah, we have a load effect. We also have time involved in this, yeah? Some pollutants have an effect the minute they're released. So oil spill into the sea has an effect immediately, but other pollutants actually have an effect that change over time. Fertilizer, chemical fertilizer, is used throughout the world to improve growing yields. Yet, if we use too much chemical fertilizer, it can get into our watercourses and cause eutrophication. It has a secondary effect, yeah, and that can build up over time as well, yeah. So again, going back to examples from Vietnam, yeah, in this case, you can see there's a lot of rubbish being dumped on this side of a hillside here. The refuge system, the trash system, quite often means the dumping of things that don't break down. So we get the build-up of this waste that starts to break down but may cause problems elsewhere. So as it breaks down, it actually releases more pollutant problems that eventually get into the water systems and spread on. Yeah, so we have pollutants changing over time. A really great example of seeing that was measured very, very well, so we can see exactly what happened. The Chernobyl disaster in Ukraine, that was then part of Russia, released cesium-137 into the atmosphere. You can see from the graph that over the time, the amount of cesium that travelled across the west of Europe actually increased dramatically. Yeah. To the extent that was 1996, there are still farms in the west of Britain that, because of the rain patterns during that time, got a really high load of cesium-137. Those farms are still affected. So the levels of radiation increased over time as air movement and as rain particles eventually washed the cesium out of the atmosphere. Maystruck and Abdel created this really nice little diagram in 2011 that sort of looks at the way pollutants work inside both the animal and plant kingdoms and the environment and the interactions within them. So we have interactions going on all the time here. So not only do we have the pollutant itself, we have the pollutant maybe being taken up by plants, then animals eating those plants that take on that. So we have all of these complex feedback mechanisms happening within pollutants. Minamata Bay and the uptake of mercury, that was a feedback system through pollutants being released into the water system that were eventually taken up by shellfish that eventually got eaten by fish that eventually got eaten by farmers, by fishermen who went out fishing. That eventually created mercury poison in the human population. So we have lots of these feedback mechanisms. And if you remember, Minamata Bay we looked at when we looked at a timeline of environmental effects and environmental drivers of the environmental movement earlier on. So, DDT. In the 1940s, DDT, a chemical pesticide, was widely used. It was seen as the answer to famine and farming throughout a lot of the world. It killed off a lot of pests. It was seen almost as a miracle cure for the problems of famine around the world. However, by the 1960s, worries started being raised, and Derek Radcliffe in the UK in particular created a link or found a link between DDT being sprayed on the land and the effect that it was having on top predators, in this case the peregrine falcon in the UK. Eggshells of peregrine falcons got thinner and thinner because of the effect of DDT, not on the falcon itself, but on the insects that were being eaten by the small mammals that the falcons themselves were eating. We were getting a biomagnification effect, yeah? That eventually got to a tipping point until the populations crashed, yeah? And the populations in the 1960s of peregrine falcons crashed. The use of DDT was banned in the 1970s in the late 1960s in the United Kingdom, across a lot of Europe, and the falcon population now has recovered dramatically, yeah? And over the years it's recovered through the ban of that. However, following the Stockholm Convention, the use of DDT was banned around the world entirely, except for the use of vector controls. DDT is a very, very good controller of the malaria mosquito. So in the areas where malaria mosquitoes act as the vector for malaria, DDT is still used. It's a very, very specific use. However, there are still countries that may be using DDT for agricultural purposes. India and North Korea still use DDT. So we haven't entirely got rid of those sorts of problems. So, pollution management. We have 3 levels of pollution management. Yeah, we have the processing thing. It's a human activity that produces pollutants. We can actually look at changing that through education, campaigns, governmental legislation, economic incentives, yeah? Change human activities that lead to the production, the need for those in the first place. Our second level is about controlling the release of pollutants. So there's a lot of legislation. The release of DDT in the environment is legislated around a lot of the world, yeah? And changing the technologies for extracting the pollutants from emissions. A lot of power stations have scrubbers on them to actually remove particle and carbon dioxide and carbon monoxide and NOx pollutants. It doesn't entirely solve the problem, and as limits increase, or as the minimum limits decrease, that technology is becoming out of date, which leads us on to the last sort of idea of it, which is clean up and restore. This is really something we don't want to be doing, yeah? Damaged systems don't always respond to going back to as they were, but we could extract and remove the pollutants, yeah? So what we have is 3 levels of pollution management. Since the early 2000s, a lot of legislation to limit and ban the use of plastic bags and packaging, yeah? However, it's really changing the attitudes of people, yeah? This removes the problem rather than just mitigating the problem. Level 2 and level 3 only mitigate, yeah? But working on level 1, changing attitudes, is the best way of probably changing the problems of pollution for the future. So it acts in these 3 levels, yeah? The first level, changing attitudes, is much, much better than developing clean technologies, which is then much, much better than actually cleaning up. So hopefully there's some understanding being developed there about us as humans and the effect that we have on the environment through pollutants. Throughout the course, throughout the ESS course, you will keep on coming back to this, to these interactions. So as always, we have work cited. So these are actually worth going and having a look at. We'll give you some more background. And if you really want some extended ideas and interest in this, there are 3 references here that will really, really help. So I'll leave those up for a minute or 2, and thank you very much for viewing this lecture.